Welcome to the Pacific Northwest Geodesign Forum. I'm Tim Nyergis, Professor of Geography and Director of the Masters of GIS for Sustainability Management. I'd like to take this opportunity this morning for thanking you all for signing up, registering, being here this morning at this early hour. Hopefully a number of other people will arrive in due time, as it would be. And I'd like to take this opportunity to acknowledge the sponsors of the activity. This event wouldn't occur, at least the students, for there is a free lunch in the world every now and again for students. Students didn't have to pay a registration fee. So the 4 colleges from the University of Washington came together, or at least units, I should say, from 4 colleges came together. The College of Arts and Sciences, with the Department of Geography and the Division of Social Sciences, the Master of GIS Program for Sustainability Management within the Department of Geography. From the College of Built Environments, we have Landscape Architecture and Urban Design and Planning that are part of the Planning Committee. From the College of Engineering, we have Civil and Environmental Engineering. And as engineers, sometimes, as it would be, I'm a geographer, a would-be engineer, as the case would be, I think, all these years. The engineers sometimes have a little bit deeper pockets. They didn't even want to bother to go to their dean for money because they had enough to contribute themselves. So that was quite nice for the faculty to get together and do that. From the College of the Environment, we have the School of Environmental and Forest Sciences. And last but not least, the National Science Foundation funded project. It's called the Cyber GIS Project. It goes by the formal title of Software Integration for Sustained Geospatial Innovation.
At this point, I'm going to introduce our first speaker today, Mr. Bill Miller. So Bill is an architect and an engineer with over 50 years of practical experience and a lead designer in a number of fields, including environmental planning, GIS, industrial design, software development, and education. He has completed geodesign projects around the world, including power siting, plant siting studies, highway routing analysis, community master plans, and a variety of environmental studies. In the late 90s, Bill set up and taught the first environmental design studios at the University of Redlands, where he later went on to found the Center for Environmental Management, now known as the Redlands Institute. He has served as an advisor to various organizations, including the Landscape Architecture Foundation, the Buckminster Fuller Institute, NatureServe, and Community Viz. During his 20-year tenure at Esri, still hard for me to say sometimes, Bill has served as the lead on many projects, including those that were very important to GIS users, including the development of Model Builder, ArcSketch, Esri's Virtual Campus, and more recently, the Landscape Planner, Esri's new web-based application for geodesign. Prior to his retirement, he served as the Director of Geodesign Services at Esri and is now the Principal at Intuigence, I can say that, and is currently advising a number of universities regarding the emerging field of geodesign and how designers can use geospatial information to help inform the design process. And it's a particular honor for me to introduce Bill because he was a positive influence on my own career while we were both at Esri. He was especially helpful in helping me understand and assist the business partners in using Model Builder to strengthen their spatial modeling tradecraft. And he also helped me grasp the important role of designers in the world of GIS, which ultimately led me to geodesign. For that, I am grateful. Bill's presentation today is Why Geodesign, Its Character and Benefits. With that, Bill, the floor is yours.
Thank you very much for the introduction, and Tim, thank you for inviting me to this forum. It's a pleasure for me to be here this morning. Tim attributed me with coining the term geodesign. That is not precisely correct. About 7 years ago, I was leading a small development team to develop a tool called ArcSketch, which was an add-on to ArcGIS. And we were giving a presentation to Jack Dangeman. Mike Blacksman was in the room also. I don't know if he's come here yet. The programmer who developed the drawing tools for ArcSketch was actually drawing a concept plan on top of a GIS layer. And I turned to Jack and I said, see, Jack, now you can do design with GIS. And Jack says, geodesign, like that. And so that term fermented in our space for about a year and rose to the surface. And since that time, Esri has had 3, 4, 5 conferences on geodesign. And the first few conferences were about who can define geodesign first. And my definition is better than your definition. And later on, the more recent conferences actually show a lot of substance of people really doing geodesign. So I've been asked to kind of warm us up to the idea of geodesign, what it is and why it's important. And I like to define geodesign very simply at a high level. Okay. Geodesign is design in geographic space. So geodesign is design in geographic space. Now what I mean by geographic space, when I ask you about geographic space, I'll probably get an answer, well, it's a map. And if you're more sophisticated, it's an undulating surface with a map on it, so it looks like a 2.5D map. And then if you're in the field of GIS, you extrapolate that and you say, well, I can drape layers on top of that. So it's an undulating surface of a map, and it has a soils layer on top of it, and it has a agricultural potential layer on top of that, or it has a walkability layer on top of that. And we're thinking in terms of this superficial environment. But the geodesign, geospace, right, geographic space, is actually broader than that. I define geographic space as the planet's life zone, everything on, above, and below the surface of the Earth that supports life, which includes not only the biology of life, but social systems, economics, politics, military, everything, right? So if we think in terms of geodesign and we define geographic space as the planet's life zone, that's a much broader definition. Right? This can help us move out of the areas that I'm actually worried about because they're hijacking the term geodesign, and that's regional planning. So when people talk about geodesign, they actually mean in their own mind geoplanning, or use the word to define something they've been doing for years, right? But if you redefine geographic space as the planet's life zone, it opens up a whole number of possibilities, and I'll describe one for you in a moment. The other aspect of geodesign is the word design. I think design is misunderstood more than any other term that I can think of. So I'll give you an explicit definition of design, and I'll ask you about what is missing in this definition. So the definition of design is the thought process comprising the creation of an entity. Design is the thought process comprising the creation of an entity. So it's rational thinking, it's intuitive thinking, it's insight, it's extending your thinking with tools, it's the thought process. Now, what is an entity? An entity can be an object that occurs in space, an event that occurs in time, such as this workshop. It can be a concept like the theory of relativity, or it can be relationships, as the relationship between man and machine, which might be exemplified in the Apple operating system, right? Or the relationship between a friendly nation and an unfriendly nation. Right? So design is the thought process comprising the creation of an entity. An entity can be one of these 4 things. Most probably it's a complex entity. In other words, it's partly relational, it's partly object, it's partly event, it's partly concept. Right? So if design is a thought process comprising the creation of an entity, that sounds pretty broad, but what is missing? How do you know if design is good or bad? That definition doesn't give you a clue. So the ethic for design, whether design is good or bad, comes from the purpose of design, which in my mind is always the same no matter what it is you're designing. The purpose of design is to facilitate life. If the design facilitates life, it's good. If it inhibits life, it's bad. If it does neither, it's neutral. So take this definition of design, the thought process comprising the creation of an entity, intersect it with this new definition of geographic space, right? With the intent to facilitate life. Whose life? Your life, the life of the people that use the entity, the life of the people that have to support it over time, the life of the people that are affected by it later on, right? The impacts, etc. This is now a very broad field of geodesign, right? It's not just land use planning anymore, not just environmental management. It's looking at how we create solutions for problems that exist within our planet, large or small, that take into consideration the context of the geographic components surrounding and making up that environment, right? So if you're going to design an entity, geodesign would say that you're going to consider the geographic context for the entity, respect to how that in context informs the geodesign the design process, and how it's affected by the results of what you propose. Right? Does that help you get a broader definition of geodesign? Now later on today, you're going to see that qualified by saying geodesign is only geodesign if you use computers, if and only if there's collaboration, if and only if there's feedback, and if that feedback is only instantaneous, right? And so there's a whole bunch of modifications that you can apply to this definition, but I wanted to present it to you this morning, give that broader picture. So here's my concern. If I walk into a course on regional planning or landscape architecture and look at the problems the students are working on, there will be a greenway, an open space plan, a land use plan, an urban design problem like that. No one is addressing this problem. Students, I want you to consider the conflict in Kashmir between Pakistan and India. I want you to spend half the semester understanding the nature of that conflict. The other half, I want you to propose a solution that is economic, social, environmental, political, military, religious, doable within the next 150 years. No one is assigning a problem like that to a student, right? So we're teaching people how to solve small problems, not big problems. One aspect of geodesign is embracing the larger problems that we're facing and teaching ourselves and our students how to address them. So would the students present a workable solution to resolve the conflict in Kashmir in 13 weeks or 18 weeks, right? However long your semester? Probably not. But they would have the experience of addressing a problem that was large and complex, where the objective functions were changing over time, the people that were being served by those objectives were changing over time, and the design team was changing over time. We're not addressing problems like this. So when a serious problem occurs in the world, we send in a singular solution. We send in a lot of money. We send in a military force. We send in negotiators. We don't develop a comprehensive long-term solution that can reside in this longer time frame. Right? So we're not teaching people how to be impresarios of the opera. We're teaching how to be lighting professionals, costume designers. We're teaching them how to sing, how to promote, how to take tickets, how to manage the business aspect. But we're not teaching them how to be impresarios. So that's a broader context for geodesign. Now, why is geodesign important? One of the reasons geodesign is important that Bryant mentioned is that it provides the intersection between design, the act of creating something, and science of information that surrounds that. So using GIS and geodesign thinking, okay, you can use that platform to bring in information from the social sciences, the physical sciences, the economic sciences, right? And that can be the background, the context to help inform you as to how you do your design work for whatever you're doing. Now, if you're designing a land use plan, an example would be that as you draw in the polygon where you're going to put housing, it instantly overlays the wetlands and shows you we're in conflict with wetlands. Right? That'd be a very simple example. Right? But if you had 100 layers to work with and you're designing, that information can inform you. You could either accept that area as a wetland and you're going to remediate the conditions there, or you're going to avoid it. Right? So geodesign from a technology point of view and with GIS allows you to intersect the science information with the design attitudes and values. Right? One of the challenges that we faced at Esri when we were talking about geodesign was actually developing design tools that were usable. Right? So that was one of the intents behind the development of ArcSketch. We wanted to be able to give the designer tool to sketch like they would with pencil and paper, and as they were drawing, they automatically created a geodatabase on the fly which kept track of all that information. And we were successful in the sense that a large environmental design firm, EDA, I don't know if you know them or not, they were considered the largest landscape architecture firm in the world for many years, and they were purchased a few years ago by AECOM. They had a number of partners. They were asked by a major landholder in the United States to evaluate 100 parcels of land, the various sizes, to determine what their highest and best use was. And they called me and asked if they could use this new ArcSketch tool we're developing. And I said, well, you know, it's in beta and it's really buggy, and probably you don't want to use it right now, right? And you surely don't want to use it with an important client, you know. And thank you. And so they said, well, we need to use it anyway. So they used ArcSketch with 10 of their partners who did not use CAD or GIS. They were designers, landscape architects. And they used this ArcSketch tool to sketch out concept plans for those 100 properties and then evaluate them from an environmental point of view and an economic point of view present the results back to the client within the context of an intranet. And they were successful in the sense that they did it for less time and money than they expected. So we were very happy about developing a tool that was easy to use by people who were not, technologists. Right? So then Esri adopted that tool and put it into their software. They wrapped around all the complexity of ArcGIS. So once you got to it, it's easy to use, but you couldn't get to it because you had to be a GIS jockey to get to it. Right? So I've been noted that I have 5 more minutes. I'd like to propose a challenge to all of you that I would like you to think broader in terms of geodesign. And for those in the academic field, students and faculty, think about assigning some larger problems that teach the students how to handle the complexity and where the object function changes over time. Right? And one of the things that's missing, I think, in the academic community when people are in these types of design studios is that we don't teach enough problem-solving methodologies. We don't bring people in from the fields of operations research to augment our program. And there's a whole raft of information and methodology and science of design in operations research that could be applied to this area that's not being applied today. So I'd like to take a few minutes now to let you ask a few questions. I'll try to answer them the best I can. And in the interim, I thank you for letting me talk to you this morning. So any questions out there? Okay, thank you.
Most complicated project you've worked on from a geodesign perspective? And you might be able to go back way back.
Well, the most recent project is most complicated.
Most complicated.
Most complicated. Most complicated is also most recent.
Okay.
I wanted to develop have Esri develop a tool to do geodesign, right? And it took 2.5 years to get Esri's attention that they should do this. Took another year to get it done, right? And the complexity was not in the technology, was in the politics, right? I think that's where a lot of the complexity is in problems today, right? That's been the most complicated one, right? But that tool is now called GeoPlanner, right? And it's available tomorrow, and you can probably find it on our ArcGIS website, right? Where it's a web-based application that allows you to set up a project, manage the data for that project, assess the existing conditions, develop alternate design scenarios, evaluate those scenarios, compare them, then harvest content out of that process for your reports. It all runs on the web through ArcGIS Online. Any other questions? Yes. Right. Right. I think this is a relatively untouched area, and the answer that I can't give you a good answer. I can tell you the conditions at Esri. We have PhDs in hydrology, in agronomy, in land use planning, in computer science. We don't have not one spatial economist in our organization. Right. So this is a huge challenge, and I would think this is another challenge for people in academia to set up a studio where the students were taught how to evaluate things economically in a spatial environment and what constitutes benefit. Right. You ask a very important question, and I don't have a good answer for you, but it's an area of research and application development that's very important. Yes. Right. So are you familiar with design charrettes? Okay. A design charrette would be typically a local government would organize a 3-day workshop where they bring in citizens and professionals that have an interest or stakeholders for a particular problem. and they work on it for 3 days, and they bring in architects and landscape architects to work with them, and they bring their felt tip pens and maps, and they just do a big brainstorming explosion of what's possible. Right? What typically happens is they come up with some of these wild ideas that are not implementable because they cost way too much money or not politically acceptable. Right? So what could happen is that GIS could be used to bring in the scientific information, the factual information, and they could actually do their sketches in geographic space with GIS as opposed to felt tip pens, right? And which would be informed by the science and the economics of the area and the interests of stakeholders, right? And Mike Flaxman, who may or may not be here today, I'm not sure, has done this work before, and I'm sure he'll talk about it in his later presentation. Good question, thank you. Anything else? Okay, thank you very much, appreciate your time.